Thank you for being here today. First of all, I would like to thank the organizers for this kind invitation and for giving me the opportunity to revisit some research I carried out during my PhD, approaching input from a different perspective. In particular, I will focus on certain aspects of Gino Fano's work with the aim of identifying traces, references, and influences from the Bericht by Brill and Noether. I would like to clarify that I am not an expert of this specific work, but it is particularly stimulating to retrace some key stages of Fano's biography and through this lens. This case study offers an interesting angle to explore the mathematical dialogue between Germany and Italy between the late 19th century and the early 20th century. It is therefore a real pleasure for me to share with you some of this reflection in this talk, hoping that the content of this ongoing investigation, still very much work in progress, may be of interest to you. I will divide the talk in three main parts. First, I will provide some background information on Gino Fano's biography, with particular attention to the years of his education and early career, which were strongly shaped by his contacts with the German mathematical community. I will also briefly touch upon his conception of the so-called Italian school of algebraic geometry, to which he felt a deep sense of belonging. Then I will move on to analyze Fano's references to the Entwicklung, as well as more broadly his engagement with Max Noether's work. I will focus in particular on two key moments: his essay published in the German encyclopedia at the beginning of the 20th century, and his activity as a scholar engaged in high-level mathematical dissemination abroad. This latter aspect is, I think, especially relevant since it is precisely in this context that Fano explicitly highlighted the cultural roots and intellectual references that shaped both his own mathematical outlook and that of the Italian school. I will also offer a brief comparison between section 5, part E of the Bericht, and selected passages from Fano's course of higher geometry, where several points of contact emerge. Finally, I'll discuss the role attributed to Max Noether in the eyes of Italian geometers, with Fano's narrative serving only as one example of a broader shared perspective, as we will see, and I will offer some concluding remarks. For this research, alongside the existing literature on the Italian school, I have made extensive use of unpublished documents, most of which belong to the Fano archive, housed at the Special Mathematical Library of the University of Turin. Some of these documents are also accessible online, thanks to the work coordinated by Professor Livia Giacardi. So let me start by providing some background on Fano's trajectory. He was born in Mantua in 1871, and he was the first of the group of Corrado Segre's disciples. Fano made pioneering contributions to the algebraic geometry of trifolds, establishing himself, as Beniamino Segre recalled, as one of the most significant followers of the glorious Italian geometric school. His career was closely intertwined with the University of Turin, where he spent over 50 years, first as a student and later as a professor. Here he began his university studies in 1888, at a time when Corrado Segre had just been appointed professor of higher geometry and was broadening his research horizons under the influence of the German school, particularly Brill, Noether, and Klein. The early years of Fano's career were thus marked by strong connections with the German mathematical community, as I will discuss shortly. After spending some years in Rome and later in Messina, Fano was appointed to the chair of projective and descriptive geometry at the University of Turin in 1901, a position that he held continuously until 1838. For Fano, these were years of intense work, not only in research and teaching, but also in scientific dissemination, a commitment exemplified by the lecture series he was invited to deliver in Aberystwyth in 1923. Remarkably, this engagement with dissemination continued even during the years in exile, when he gave 5 talks at the Cercle Mathématique of Lausanne. Indeed, following the racial laws, Fano was forced to emigrate to Switzerland, and after the war, he divided his time between Italy and the United States, where his sons Ugo and Robert lived and worked. As anticipated, Fano was fully aware of his belonging to a well-defined scholarly group known as the Italian School of Algebraic Geometry, whose distinct features have been analyzed by contemporary historiography. This group shared common cultural roots, both in terms of foundational texts, among which, as we shall see, the Bericht by Brill and Noether certainly stand out, and key figures regarded as masters, such as Luigi Cremona, Giuseppe Veronese, Eugenio Bertini, and above all, Corrado Segre. Under his guidance, between 1891 and 1912, the Italian School of Algebraic Geometry took shape, and within just a few years, Italy came to occupy a leading position on the international scene, thanks to the groundbreaking contributions of Guido Castelnuovo, Federico Enriquez, Francesco Severi, and many others. At the time, the existence of a school with peculiar identity was evident not only within Italy, but also in the eyes of the international community. Italian geometers shared not only a common corpus of readings, academic references, and research teams, but also a distinctive methodological approach in which geometric intuition played a fundamental role, closely intertwined with heuristic reasoning and experimental procedures. Fano himself underlined the importance of this experimental dimension, which, as he wrote, generally consists in the attentive examination in the detailed analysis of some special examples, further adding that in our intellectual laboratory, experiments may be carried out. He also frequently referred to what he called the Italian or geometrical method, grounded in the use of analogies and hyperspatial techniques, such as projections and the study of hyperplane sections of algebraic varieties, as illustrated in the manuscript shown here in the slide. Moreover, Fano openly acknowledged Segre as the new leader of Italian geometry, the founder of a new school, emphasizing his exceptional ability to learn, to make his own, and to let estimate by his pupils all that for the development of this program was to be got from the most important foreign mathematicians, among whom Noether's name appears. Fano's research activity was shaped not only by Segre and Castelnuovo, but also, as Alessandro Terracini pointed out, by certain aspects of contributions of Cremona in one of the multiple directions of continuity in Italian geometric thought, a thought and a continuity into which Fano was able to insert himself. This sense of continuity and of belonging to a school was something Fano valued deeply throughout his career. Let us now turn to what represented for Fano his first direct contact with German mathematics. In 1889, Corrado Segre entrusted him with the translation into Italian of the famous Felix Klein's Erlangen program, having long recognized its importance for the development of geometric research. On this occasion, Segre wrote to Klein these words: "This work is not, in my opinion, well enough known to the young Italian geometers, and it is especially for them that I wish it to be reprinted." Fano's translation, which was the very first translation of the Erlangen program, was published in 1890 in the Annali di Matematica Pura and Applicata, under the title Considerazioni comparative intorno a ricerche geometriche recenti. This marked the beginning of Fano's relationship with Klein, a connection that would prove significant for multiple perspectives. 2 years later, in 1892, Fano graduated with a dissertation on hyperspatial geometry, supervised by Segre, but also influenced by Castelnuovo's research on curves of the highest genus in projective space. The following year, Segre sent him to Göttingen for a study period under Klein's guidance as a way to further his training. At the end of the 19th century, German universities were the preferred destination for Italian mathematicians seeking to refine their expertise, representing a key reference point for young researchers. Since 1883, Segre himself had maintained regular correspondence with Klein, and in the summer of 1891, Segre and Gino Loria had visited several major German institutions. Against this backdrop, it's not a surprise that Segre chose Göttingen for Fano's training. In his letter of introduction to Klein, Segre wrote that Fano is gifted with a great memory and has a lively mind, but his tendencies are essentially directed toward geometry, pure geometry. And even though Segre wrote, I have repeatedly encouraged him to cultivate analysis too, and in my courses I've shown not only the synthetic methods but also analytical methods. He has remained up to now to exclusively a geometer. And I believe that it is possible to strengthen him a great deal as a geometer if you can make him fully acquire the analytical tools. So Fano arrived in Göttingen in the mid-October 1893. Teaching at German University was characterized by great academic freedom and a strong focus on specialized research topics. During the winter semester and in the following summer semester, Fano attended 3 courses by Klein on hypergeometric functions, second-order linear differential equations, and elementary geometry. These courses were complemented by seminars, which, as Fano later wrote, were a very important complement, since they required active participation from students who were expected to present topics related or even unrelated to the course material. During the summer semester, Klein devoted his seminars to spherical functions and their application in mathematical physics, and Fano developed two topics, one on Fourier series and another on spherical functions. The relationship between students and professor was further reinforced by extra academic gatherings at the Mathematische Gesellschaft, where original research was regularly presented. Here, Fano delivered two lectures, one on line geometry and another on the recent developments in Italian geometry. This marked the beginning of his efforts to promote Italian geometry abroad, a mission he would continue throughout all his career. Among the students attending the seminars were Virgil Snyder, Emanuel Beke, Wilhelm Lorley, and Grace Chisholm. The latter, together with her husband William Young, later spent the academic year 1898-99 in Turin, attending Segre's lectures. Many of these colleagues maintained contact with Fano throughout their careers. During his time in Germany, Fano also had the opportunity to meet Max Noether for the first time in Erlangen in August 1894, as documented in the postcard shown here. In Göttingen, Klein came to appreciate the working methods of the young Italian geometers such as Fano, and this appreciation was so deep that in 1899 Klein offered Fano the chair of geometry in Göttingen, previously held by Schönflies, with these words: "I conceive the chair essentially as a geometric chair. That is, I wish the one who holds it to extol geometric intuition and develop geometric studies in all directions. But now, you know, the decline of geometry in the younger German generation, I have reached the conclusion that you are precisely the man for us." Fano, however, replied diplomatically, expressing his deep honor at the offer, but stating his preference for a position at an Italian university. And as his son Ugo later recalled, Fano did not want to be Germanized. The same year, following a competition, he secured a professorship at the University of Messina. Also, his ultimate aspiration was to return to Turin, which he achieved in 1901. Fano's connection with German mathematicians started during his time in Göttingen, extended to editorial collaborations as well. In September 1900, Noether enthusiastically accepted Fano's proposal to have his work on Sophus Lie, which was published in the Mathematischen Annalen, translated into Italian. Just as Segre had done with him for the Erlangen program, Fano entrusted the task to the young Adolfo Viterbi, who had graduated 2 years earlier in Messina. And the translation was published in 1903. In this regard, Noether wrote to Fano, Although Viterbi has a good understanding of the German language, it is still possible that at some point a doubt may arise regarding the meaning. In such a case, I am available for any clarification. If you yourself would like to add some notes to the article, I believe this would only be to its advantage. This exchange is a clear sign of the ongoing dialogue between the Italian and German mathematical communities. One of the most striking examples of the close ties between German and Italian geometers is the significant participation of Italian mathematicians in the geometric section of the Enzyklopädie der Mathematischen Wissenschaften, a publishing initiative that played a crucial role in the consolidation of Segre's school. Once again, Fano was a key figure. After returning from Göttingen in the summer of 1895, he engaged a lively correspondence with Franz Meyer to finalize the content of some chapters on geometry, keeping Guido Castelnuovo promptly informed, as evidenced by these letters. Yeah, because it's a letter of Fano to Terracini that remembered the years when he was involved in this project. The others are from Fano to Castelnuovo of those years. And in one of these letters to Castelnuovo, Fano cited also the Bericht by Brill and Noether, stating that Brill and Noether in the algebraic field are everything one could wish for, or at least it is not easy for anyone to do better than them. At the end, Fano authored two essays for the German Encyclopedia, both published in 1907 and enriched with valuable historical insights. One on continuous group, and the other on the dialectic between synthetic and analytical geometry throughout the 19th century. The third volume of the encyclopedia, devoted to geometry, clearly bears the mark of the Italian school. In addition to Fano's contributions, it includes essays by Corrado Segre, Enriquez, Castelnuovo, Loria, and Luigi Berzolari. Fano not only owned a copy of this encyclopedia in his personal library, but he was also one of its most active contributors, traveling to Germany several times to attend editorial meetings, at least until the 30s. This brings me to the second part of the talk, where I'll try to examine Fano's engagement with the Bericht and with Noether's work more broadly. Brill and Noether's work serves as a fundamental reference from Fano in his encyclopedia essay, which focuses on the historical development of analytical and synthetic geometry throughout the 19th century. Moreover, it is one of the 6 works listed at the beginning of the chapter as a part of the general literature, highlighting so its foundational significance. The other works cited here are by two German mathematicians, which are Klein and Kötter, two Italians, Gino Loria and Ernesto Pascal, and the Aperçu historique by the French mathematician Charles. To further demonstrate Fano's high regard of the Bericht, it is interesting to compare the approaches to algebraic geometry outlined by Brill and Noether at the beginning of the fifth section of their work, approaches that they described as the more recent directions in the theory of algebraic functions, which are not purely functional theoretic in nature, with what Fano defines as the methods for studying geometry on algebraic curves and surfaces, which were presented in the paragraph 32 of his encyclopedia essay. Also, Brill and Noether, in the rest of their discussion, focused mainly on the first three approaches they listed. They actually identified 5 distinct directions. 3 of these closely correspond to 3 of the 4 methods highlighted by Fano. The first is the algebraic geometric direction, where Brill and Noether themselves played a leading role, while Fano here referenced Eugenio Bertini as a key figure. Brill and Noether named Riemann, Roch, Klebsch, and Gordan. The second shared aspect is the arithmetic direction, which Fano called algebraic arithmetic, with Dedekind, Weber, and Kronecker as the main figures. The third is the geometric direction, or as Fano explicitly called it, purely geometric, strongly characterized by the work of Italian geometers starting in 1888. Fano also separated out the functional method derived from Riemann's work on abelian integrals, while Brill and Noether instead explored different perspectives within their second and third points of the list, which are the algebraic direction, represented by the lectures of Kronecker, Weierstrass, beginning in 1860, and Christoffel from 1880, and the so-called direction of invariance or algebraic theoretical forms, represented by Weber, Noether, Christoffel, and Klein, with additional contributions on radical functions from Frobenius and Scotti. The fifth section of the Bericht of Brill and Noether is explicitly cited by Fano also in the section 31 of his essay, devoted to Klebsch and to some remarks on the study of transcendental functions. In the same section, Fano also referred to Noether's extension in 1871 of the notion of birational transformation from plane to space, an idea then reintroduced by Cremona. The following section is devoted to geometry on algebraic curves and surfaces, and Fano naturally referred to the fundamental paper by Brill and Noether published in 1874, which laid the foundation for the geometry on an algebraic curve. He also cited 2 works by Noether, which, according to Fano, represented the earliest research in the field of transcendental geometry. In this contribution, In these contributions, Noether introduced double integrals for algebraic surfaces, which were the natural higher dimensional analog of the first kind abelian integrals for curves. Of course, Noether's work also appears in other parts of Fano's essay. One particularly significant reference is in the section on the theory of algebraic space curves, where Fano recalled Noether's fundamental contributions and emphasized that his 1882 paper, which was awarded by the Berlin Academy, represented a decisive advancement in the field. Three more of Noether's papers are cited in the section entitled Refinement and Development of the Projective Concept. Here, Fano highlighted Noether's role in having already considered the n-dimensional case in his studies on birational correspondences between algebraic curves and surfaces, as well as his analysis of the general intersection of two algebraic varieties in n-dimensional space. Now, at this point, one might be tempted to think that Fano's references to German works in his essay were in some sense required, given the context of the German encyclopedia. However, what I would like to emphasize is that for Fano, the contributions of German mathematicians were much more than a formal or diplomatic homage, because they were a true intellectual point of reference. This becomes even clearer when we shift the focus to Fano's activity of scientific dissemination abroad, where he shaped and promoted his own narrative of the Italian school, always in dialogue with German tradition. An important example of this is Fano's visit to the University College of Wales in Aberystwyth in 1923. Thanks to his connections with Grace Chisholm and to the reputation he had built, Fano was invited to deliver a course on Italian geometry. As one of the students would later recall, not without some humor, Fano's English was rather eccentric, but he wrote but students could rely on lecture notes translated into English with the help of Fano's sister, Maria Ettlinger, along with Grace Chisholm and George Scott, who was then a lecturer in applied mathematics. Beyond his university lectures, Fano also gave two popular talks, both of which offer valuable insight into the key themes that shaped his personal vision of science. The first, entitled Intuition in Mathematics, tackled the question of whether mathematical work is purely logical. Here, Fano stressed the essential role of intuition, writing that particularly in the science which is still in the course of construction, the part played by intuition must be a great one. Intuition is the true helpmeet of invention and is the pioneer of progress and points the way to logical development. The second talk, All Geometry is Theory of Relativity, opened with two simple but profound questions. What is a geometric figure, and what is a geometric property of this figure? In response, Fano first explained that geometric objects such as points, lines, and planes are abstracted from reality. And to answer the second question, he introduced the concept of transformation groups and explicitly cited the Klein-Erlangen program, which classified different geometries based on the properties that remain invariant under a particular group of transformations. In the University of Liverpool archives, within the papers of William Young and Grace Chisholm, only the typewritten notes of Fano's lectures on Cremona have survived. However, in the Fano archive in Turin, we find a rich manuscript collection which preserves multiple drafts of these lectures. These materials offer a vivid snapshot of the intellectual atmosphere within the Segres school, conveying both the enthusiasm and the strong sense of belonging to a collective research effort, something that Fano often underscored, both in Aberystwyth and elsewhere. This sense of community is evident from the very opening of the lecture series, where before introducing Cremona transformations, Fano remarked, if Italy's contributions to modern geometry are very important, I'm only a very modest representative of this geometrical school. I hope to succeed in suggesting you the interest of the matter. Over the course of about 20 lectures, Fano covered 8 broad themes, starting from Cremona and his successors, and arriving at the most recent research of the Italian school, all the while emphasizing connections with international research, and in particular with German mathematicians. Throughout the lectures, references to German geometers and especially to Noether are frequent and significant. So let us now take a closer look to the specific areas of Italian geometry that Fano linked to Noether's contributions. One such reference appears at the beginning of the second section of the lectures, titled Some Notions Concerning Clebsch and Noether. Here, Fano recalled that the so-called geometry on algebraic curve is concerned with studying groups of points or set of points on a curve and their linear series. And he noted that the necessary material already existed in Germany, given by Riemann and by a memoir of Brill and Noether, and add, but it wanted to be brought in contact with Italian research as it was about 1890. Fano emphasized that in addition to the key notion of characteristic series and of a linear system, it was necessary to introduce the concept of the adjoint system, which, as he explicitly pointed out, was already considered by Brill and Noether for a single curve. Another point in the lectures where Fano referenced Noether's contributions concerns Cremona transformations. Fano described them as constituting a new instrument of investigation for science, such as was applied, for instance, by Noether to the singularities of plane curves. When discussing Cremona's work in the representation of the so-called rational surfaces of the plane and of birational transformation in space, Fano remarked that Cremona had repeatedly come into contact with Clepsch and Noether. However, the area where Noether and Brill made the most significant contributions was the geometry on algebraic curve, a topic to which Fano dedicated attention in the sixth part of his English lectures. Among the other things, he cited Noether's classical theorem on the possibility of representing, in certain cases, a plane curve in the form AF plus B phi equal to 0, where F and phi equal to 0 are given curves, and A and B are suitable polynomials. Besides citing Noether's work on algebraic surfaces, already mentioned in the encyclopedia, in his encyclopedia essay, Fano in Aberystwyth also referred to two additional contributions, one concerning the Riemann-Roch theorem, and the other regarding operations on linear systems. Even in the section devoted to the methods employed and the results obtained by Italian geometers, as well as their connections with Picard's theory of integrals of total differentials on surfaces, Fano did not fail to mention Noether's fundamental contribution to double integrals on algebraic surfaces. To sum up, the analysis of this collection of manuscripts, which includes various English versions of the lectures and, in some cases, the Italian version enriched with afterthoughts and addition, has shed light on what Fano himself described as the intellectual laboratory, highlighting the significant role he attributed to the collective work within the school. This collaborative environment, according to Fano, led to fecundity, a process to which energies are summed, energies of investigators are summed, and their discoveries followed each other rapidly. Furthermore, the works of Brill and Noether emerge as a cultural route for the Italian geometers, providing a foundational reference point for their research. This is further confirmed by what would turn out to be Fano's final experience of scientific communication abroad. At the threshold of his 70s, forced to flee to Switzerland due to the racial laws and his Jewish origins, Fano was invited by Georges de Rham to deliver a series of lectures at the Cercle Mathématique in Lausanne. On that occasion, he gave 5 lectures on Italian algebraic geometry, framed within a historical and school-oriented perspective. The first 2 lectures offered a broader context, an introduction to the development of geometry in Italy over the previous century, followed by a lecture on algebraic surfaces. Together, these 2 talks contained no fewer than 11 references to Noether's work, including the Bericht. The remaining 3 lectures focused on more specific topics, 2 central questions related to cubic surfaces, namely the problem of the existence of the 27 lines on the cubic, and the configuration known as the Sylvester's pentahedron. The fourth lecture is on certain special surfaces of degree 4, particularly Kummer and Steiner surfaces, where Fano once again referred to some Noether's results concerning algebraic surfaces. The final lecture instead was devoted to birational contact transformations in the plane, a field in which Fano himself had made some original contributions. Already in his first lecture at the Circle, Fano outlined what he considered the three main perspectives from which algebraic geometry could be approached: the transcendental functional one, the algebraic approach, and the algebraic arithmetic approach. According to Fano, the second approach, the algebraic one, was initiated precisely by Brill and Noether with their 1874 work, which he cited here alongside the well-known AF plus B phi theorem, providing necessary and sufficient conditions for expressing a polynomial in two variables as a linear combination of two polynomials f and phi with coefficients given by a and b, which are always polynomials. In reconstructing this line of research, Fano explicitly cited the Bericht, as he noted in the margins, alongside the contributions of Bertini, Severi, Enriquez, and Chisini, thereby intertwining the German and Italian traditions within the development of algebraic geometry. Fano's lectures also contain references to some of Noether's works that he had not previously mentioned in his writings. The first concerns the factorization of Cremonan transformation as a product of quadratic transformation, as we have seen just before, a theory which was refined by Noether in 1872, particularly in the case involving infinitely near base points. In addition, Fano recalled Noether's research on birational transformation between two spaces, connecting these with Cremona contributions. He emphasized how this question is nevertheless intertwined with the representation of surfaces on a plane defined by the formula number 1, in relation to which he added Cremona's work also intersected with that of Klebsch and Noether. Naturally, given the focus on the second lectures, algebraic surfaces, there are several references to Noether's contribution to the theory of algebraic surfaces, including those highlighted in the manuscript I'm showing you here. When structuring his exposition, Fano divided the study of surfaces into main aspects: those that could be addressed by analogy with the theory of algebraic curves, and those that, as he wrote, presented the most difficulties in reaching a complete and entirely satisfactory result. This second category included three crucial issues: the extension of the notion of genus to surfaces, the need to identify a rationality criterion for surfaces, and the problem of exceptional curves and its connection to the birational classification of surfaces. With regard to the extension of the concept of genus, Fano noted that Noether had suggested that the genus of surfaces of degree n in P3 can be considered as the number of adjoint surfaces of degree n minus 4. This proposal would later evolve into the concept of geometric genus, a notion introduced by Noether himself. Fano also explicitly referenced the terminology introduced by Noether for exceptional curves, a notion that would become useful for the birational classification of surfaces. In particular, when discussing birational correspondence between a point and a curve, Fano distinguished between the two types of exceptional curves. First type, which are irreducible curves that can be contracted to an ordinary point to a birational transformation, what we would now call curves with self-intersections -1. And second type, exceptional curves, on the other hand, that cannot be eliminated as their self-intersection is at least 0. To further illustrate these intellectual connections, I would like to highlight some parallels with the fifth section of the Bericht and the content of the course Fano taught at the University of Turin during the academic year 1924-25. After Corrado Segre's death in 1924, Fano inherited the responsibility for the monographic course of higher geometry, a course Segre had taught for 36 consecutive years. In tribute to his mentor, Fano decided to dedicate his lectures to the Italian tradition of algebraic geometry, revisiting several parts of the 1890-91 course that Segre had entitled Introduction to the Geometry of Simply Infinite Algebraic Entities, and which Fano himself had attended as a student. Like Segre's early lectures, Fano's course notebook displayed a clear connection to the Bericht, including several passages that are nearly verbatim quotations from Brill and Noether. However, Fano did not simply copy. While drawing from this source, he adopted and reorganized the content to fit the structure and the goals of his course. Let me show briefly some concrete examples of this interplay between the Bericht and Fano's teaching. As might be expected, there are no substantial differences in the definition of the geometric genus P of a curve of degree n, as you can see in the highlighted formulas. The only minor variation is the notation. Brill and Noether denoted the number of cusps by Z, while Fano uses R. The formula itself, which was found by Klepsch, naturally is the same. And so Fano explains to his students that the geometric genus is given by half the product of between n-1 and n-2, from which the number of nodes and cusps must be subtracted. The same close correspondence can be observed when it comes to the moduli space of algebraic curves of genus P, which parametrizes all isomorphism classes of curves of the same genus. Brill and Noether had shown that this space has a dimension 3p minus 3, reflecting the didactical nature of his course. Fano explicitly computed this dimension for the cases p equal to 2, 3, and 4, and then went on to present the general proof of this result, following an argument that closely recalled the reasoning already found in the Bericht. This alignment between Fano's exposition and Brill and Noether's text demonstrate not only the influence of the Bericht, but also Fano's commitment to transmitting these foundational ideas to the new generation of Italian students, blending them into the evolving framework of Italian algebraic geometry. However, there are also some notable differences in the way certain results, although directly drawn from the Bericht, are presented and reinterpreted by Fano through a distinctly geometrical lens. This is particularly true for some theorems related to linear series and point groups on an algebraic curve, starting with the so-called resonance, also known as the Brill-Noether theorem. This result was formulated by German geometers in the Bericht, and was formulated here in an analytical language, and emphasizing its connections to Abel's theorem. Fano, by contrast, presented the resonance entirely with the framework of projective geometry. In his formulation, he said that each residual of a given group G with respect to the adjoint curves of a given order is also residual with respect to the same adjoint curves for every group within this linear series G. This shift in perspective exemplifies Fano's systematic effort to transpose the analytical results into synthetic geometry, aligning them with the core methods of the Italian school. A similar approach characterized his treatment of the reduction theorem. Interesting is that in his lecture notes, Fano explicitly noted that Noether called it that, a reference that closely echoes the wording in the Bericht, where Brill and Noether wrote, later referred to by Noether as the reduction sets for algebraic functions, but to be designated as a special case of the rest sets for fixed points. Once again, Fano deliberately focused on the geometric formulation of this theorem. Finally, Fano, just as Corrado Segre had done before him, started the reciprocity theorem in the form originally proposed by Brill and Noether, following the path traced in the Bericht. Fano also presented it as a consequence of the Riemann-Roch theorem, which in modern terms provides an estimate for the dimension of the vector space of meromorphic functions defined on a given compact Riemann surface. This placement of this theorem within the broader framework of the Riemann-Roch results of the Riemann-Roch theorem exemplifies the structural importance that Brill and Noether work retained in Fano's exposition. At the same time, it shows how Fano actively engaged with German results, integrating them into a synthetic and projective tradition that define Italian algebraic geometry. To sum up, on the one hand, the legacy of the Bericht and more generally of Noether's contributions is undeniable. On the other hand, it's equally interesting to observe the gradual and progressive shift toward an increasing geometric perspective. This is precisely the geometric method that Segre presented in his 1991 course, a method that, as he explicitly stated, does not require functional considerations nor algebraic developments. However, alongside this geometric approach, Segre also dedicated the 8th chapter of his course to presenting the so-called algebraic method of Brill and Noether. This choice stemmed from a conviction that he repeatedly expressed, namely that all methods deserves to be studied since each one allows to view the problem from different perspectives. Fano, in contrast, more than 30 years later, chose to present only the geometric projective approach to his students, omitting the algebraic viewpoint. This shift illustrates how, over the decades, the Italian school progressively moved away from the more analytical algebraic foundations laid by Brill and Noether, adopting instead a distinctly geometric language and method. Finally, 5 minutes, if I can, I reflect on how Max Noether was perceived by Italian geometers, as Fano is not the only one to acknowledge the significance of his influence on Italian algebraic geometry. On the contrary, several members of the school regarded him as a maestro and recognized his role on various occasions when discussing the school, actively contributing to the construction of its narrative. The most famous example is probably that of Castelnuovo, who in 1828, during his plenary lecture on algebraic geometry and the Italian school at the International Congress of Mathematicians held in Bologna, remarked that Noether played such a significant role in the development of our school. However, it is not the only occurrence in an international context. As early as 1904, in Heidelberg, Corrado Segre had stated that a whole Italian school of geometers recognizes its starting point in the memoir by Brill and Noether. He then emphasized the contributions of Italian geometers, pointing out that these concepts took on a more abstract and more general character, being referred to algebraic curves. Furthermore, in 1932, Severi in Zurich, while analyzing the role of algebraic geometry in mathematics, referred to Noether in these terms. I feel compelled to pay tribute to the memory of the great German scholar, whose work has sometimes been overlooked and whom Italian geometers regard as one of their masters. We can therefore assert that Noether represented a master at a distance for members of the school, a role that was also recognized by Beniamino Segre in the opening lecture of his course on higher geometry in Bologna, where he stated, Italian geometry turned to the invariant theory of algebraic surfaces, always from the perspective of birational transformations. The foundations of this theory had been laid abroad primarily through the great work of Max Noether. Even 20 years later, in 1952, when reconstructing the historical development of Italian mathematics, Guido Zappa remembered Noether's contribution in the chapter entitled Geometry in the Last 2 Centuries, highlighting, for example, that a large part of the results on algebraic curves were rediscovered by Brill and Noether using purely algebraic techniques. To conclude, I would like to make some a few final remarks. First, we can confidently assert that the Italian school of algebraic geometry was profoundly shaped by German mathematics, with key figures such as Brill, Noether, Klein, and many others playing pivotal roles. While this connection has already been acknowledged in literature, I hope this analysis has added a further layer to our understanding of how Noether can be considered a master at a distance. His work laid the foundation for several developments within the Italian school, particularly in the study of algebraic curves and surfaces. The recognition of Noether's contributions spans multiple generations of Italian geometers, from Corrado Segre in 1904 to Zappa in the mid-20th century. Leading figures such as Castelnuovo, Severi, Beniamino Segre, and Fano himself consistently emphasized Noether's role in the growth of the Italian school, thereby solidifying his place in their intellectual history. While Italian geometry developed its own methods and applications, it continuously engaged with and built upon German theories, with Fano's work serving as a significant example of this ongoing mathematical dialogue. Returning to the Bericht, which served as a starting point for this reflection, it is important to note that many Italian geometers had access to it as early as November 1894. Fano himself possessed a copy, both in his personal collection and in the Special Mathematical Library of Turin. He was an active participant in the mathematical dialogue between Italy and Germany, a fact evident not only in distinctive aspects of his biography, but also in his dissemination activity. Fano not only integrated ideas from the Bericht in his own work and activity, but also adopted and reinterpreted them within a geometric framework, as we have seen in his lecture notes of higher geometry, while connected them to the evolving Italian school, as we have seen. Analyzing these unpublished lectures and writings reveals his commitment to advancing and narrating the Italian tradition of algebraic geometry, with German works, including the Bericht, serving as a crucial intellectual landmarks. An essential biography is provided here, and I really thank you for your attention.
Thank you, Elena. We have about 20 minutes for questions. Yeah, one really wonderful, rich talk. So I could ask many questions, but let me start with just a detail. If you could scroll back a little ways, and I have a question about that tree right there, the tree that you showed.
The first.
The tree of the.
The first.
No, the one that.
Okay. The Castelnuovo, I think.
Algebraic geometry.
Yes.
It doesn't look. That looks like a historical document.
Yes.
Did you get that from somewhere?
Yes, it is the draft of Castelnuovo's lectures at the ECM of Bologna, which is kept in the Castelnuovo archive at the Lincei Academy in Rome.
I wanted to ask you, because I can tell a little anecdote that people might enjoy. I've never seen this, but Noether had a tree that she kept in her office. The grimoire, it was lost and so forth, but one of her colleagues there mentions that this tree that she evidently got from the Italian algebraic geometers, and she was very happy about this tree because one of the big branches on that tree was Max Noether, her father. Yeah, you did bring her up, but another thing I'd like to ask about, if you can go back to when Gino Fano is asked by Franz Mayer if he would write for the encyclopedia. I think this is, I didn't know any of this, but it's very interesting, I think, because Franz Mayer was the one who had the idea originally for the encyclopedia. It was taken over by Klein quite quickly, as he always did. And yeah, no, it makes it very interesting because Fano ends up much later writing 2 articles, as you said, and they both seem to reflect quite a lot of Klein's view of things. Of course, he's the translator of Elena Scalambro, so it's not so surprising. Do you know anything about what happens afterward? Because, you know, Franz Mayer continues to be the editor of Volume 3, and so those articles are indeed nominally edited by him, but of course they're on topics that are very close to Klein's. I mean, the second one is really groups in mathematics and this synthetic analytic overview and so forth. Do you know anything more about that?
Yep. Unfortunately, we did not have the letters from Meyer to Fano, but also this testimony, the testimony of what Fano wrote to Castelnuovo. But what I think is probably derived from this letter, which was sent years later in 1951 to Fano to Terracini. Terracini was asking him some information about his early years of career, because he was prepared the celebration for Fano's retirement. And here Fano said that, so Franz Meyer wrote to me regarding geometry, proposing that I draft a contribution essentially relating to algebraic geometry, a term that perhaps did not exist. And at first I hesitated until the plan became more concrete and the division of topics was established. So what I think is that at the end, Fano did not write the first of these arguments who were asked by Meyer, because in the other letter, Fano said that this argument was completely refined in Brill and Noether's work, so that that this first part on algebraic functions and algebraic geometry did not deserve a new draft from Italian school, and then we didn't have precise occurrence of this, but at the end I think that Klein moved the interest, and then in these 2 arguments that the second with about continuous groups also was then translated by Elie Cartan in French, and so.
That's a very important article because of Cartan's reworking of it.
Yeah.
I should let other people.
Just file this one. Isn't that the 7 figures that were for mehrdimensional highway? That was for other segment groups.
Yes. I have.
Thank you very much. That's very interesting and good. So, yeah, the whole time, but I would like to first concentrate on the questions that are related on the Brill reports. Many other questions, but it struck me that Fano used it in his teaching. And so this raises the question of the function that a report of this kind might have had in teaching. So could you say a little bit more about the relationship between the historical overview and the way in which Fano taught geometry?
Yeah, I think that I'm not an expert of debate, so maybe something is incorrect, but in my impression is that my impression is that Fano properly used all these I can say historical works such as the Baked, but also in other courses, the courses of projective geometry, the upper Q by Chasles, to give an historical perspective on the matter that he was going to explore. Because, and I think that also this aspect derive both from Corrado Segre and Klein, he was fully convinced of the didactical value of the historical development of mathematics. So in all of his lectures, we always find a first part with an historical introduction, and then he started from some of this work debate in the higher geometry course, since it's about level, it's about arguments of higher level. For instance, he drawed from the Baked to present different arguments and to give the structure and the idea of these, also of the historical efforts that some results that at that time were commonly accepted by the community of geometry. The time that they have the needed to be conceived and affirmed, I think.
I was very interesting. So you had those two sets of lectures in Wales and one being obviously before and one after he was exiled. So I was wondering if there is a change in the way he relies on this national identity. So the Italian school before and after the there's any tension that he adds into this special construction once he's been forced out of it.
Yeah, it's surprising, but there are no differences. Fano was strong. Fano was Fano was strongly nationalistic, and for instance, he was convinced by his sons to leave Turin and go to Lausanne, but this was the only Switzerland was his choice, because as his son wrote, he was the only country that would not enter into the war with Italy. So Fano chose to establish himself in a neutral country, because he didn't want to stay in a country that maybe could have the war with Italy. And it's surprising, but in his public speaking, there is no change after the Russian laws. He never cited the political situation of Italy, and so there is, I think, a perfect correspondence between his lecture in Auschwitz and the lecture in Lausanne.
A few weeks ago, Erika Michel gave a talk in which she described in much detail how people like Loria, or especially the Università, were systematically eliminated from accounts of development of Italian mathematics that people like Severi were giving at the time. So clearly the historiographical transformation is
Yes.
very strong.
In fact, I had another question that went into this direction, but differently, because in Germany, there is the emergence of this discourse that intuition is the mark of Italian mathematics versus formal mathematics is the mark of Jewish mathematics. And so I would have asked the question about the transformation, about the discourse on intuition, whether there is continuity in this way of dealing with intuition, or whether on this point there is an evolution.
In Fano, there is no evolution. He was fully convinced. I think it's surprising because when he started with his training under Corrado Sega and then with Klein, and also in all the years and until his last years when he returned in Turin and also had the conference in his honor before the retirement, he continued to exalt this intuitive method and the characteristics of this way of doing geometry. Also at a time when algebraic geometry was, I think, went away from this method because also in Lausanne, de Rham had given the basis of cohomology. Fano had human, beautiful engagement with the RAM, but he didn't communicate about this working method. So in Fano, this idea is completely static, I think.
But you know, all of a sudden I realized the irony that Klein told him in the younger generation. They don't know if you come to teach.
Yeah.
I understand all of a sudden the irony of the situation.
What's the irony?
Because he's the one who insists on intuition. He's a Jew. And Klein wants him to come to teach in Germany, saying all these people in this young generation who don't know what geometry is about.
Yeah.
And these are the people who are going to claim intuition as something.
I wanted to comment about this too, because I think there's a big difference between Germany and Italy. And one of them is, of course, an awful lot of the Italians were very proud of this intuitionistic style that they had in geometry, and they dominated geometry in that period. I mean, Klein, who had, I think, much more influence on Encyclopedia than Franz Meyer did, including Volume 3, and recruited all of these Italians. He wanted that tradition to be presented. But yeah, it's totally true what Karine said, that I mean that this division between intuition and logic and so forth was racially loaded, especially later in the 1920s in Germany. I don't think, and that fits what you're saying, I don't think it's the case in Italy that parallel holds through. It's a big difference between Italian and German fascism, I think, too. The racism is a huge part of.
Yeah, in fact, also Severi, which was one of the most fascist mathematicians in Italy, he was proud of these intuition methods, and he tried to rewrite the history of Italian geometry. But at a certain point, he didn't manage to do it because there were too much results of Jewish origins mathematicians.
Because you had those nice international congresses, but so 1908 Rome is that's the congress in which the Gucci medal is given to Severi. And who are the people on the committee? It's Poincaré and Segre and Max Noether, those three. And Eminata had just gotten her doctorate, and she accompanies her parents to Rome to that congress. I think those connections are very, very important. I think algebraic geometry, subject.
Yeah.
Thank you for a wonderful talk. You mentioned at the beginning that late in Fano's life, he comes to the U.S. Does he do any professional work then? I know he's well into his 70s.
In those years, Fano went to the USA, I think only for familiar relationships, because after the racial laws, he went to Lausanne, but both his sons went to the United States. One was a physicist and the other an engineer. And they affirmed their position there. So after the war, they didn't return to Italy. While Fano was one of the first mathematicians to came back after the liberation, and then so his sons remains away, and so he went to the USA. Also by the letters, we see that he didn't have any important contacts with the American mathematicians. So the American mathematical community did not touch him in any way, but it could be useful for the development of Italian algebraic geometry, because in those years after the war, Italian algebraic geometry was essentially in a phase of decline, and but this contact didn't.
Stop here and thank Elena once again.
Thank you.